All right, you guys, let's go ahead and talk about adding and subtracting fractions now that you know how to multiply and divide them. Now, the critical thing about adding and subtracting fractions is that your denominators have got to be the same. If your denominators are not the same, then you need to write what's called equivalent fractions and then do your addition and your subtracting. So in this example, the first thing you want to do is you want to check the denominators, check that they're the same, and then you want to write down that denominator that they have in common. Your addition and subtraction will be done on the numerators, on the parts, but the whole is going to stay the same. So write down the whole, that's the first thing you do, and then add, in this case it's addition, the numerators. We get 11. But we can't keep our fraction as 11 over 8. So we divide 8 into 11. That goes one time, and we have a remainder of 3, which becomes my new numerator, and I keep the same denominator. So remember, the denominators have to be the same before you can add or subtract the numerators. There's a couple of words that you're going to need to know. Least common denominator, which is abbreviated LCD, stands for the smallest whole number that both denominators go into. Sometimes you're going to have to figure out what that least common denominator is so that you can write equivalent fractions to change your denominators. Equivalent fractions are fractions that are equal in size to the original fractions that you had. Raising a fraction means multiplying the numerator and the denominator by the same factor. And that factor is going to be based on your least common denominator. Then once you have raised the fraction using multiplication, you can make what's called an equivalent fraction that you can now add or subtract with another fraction with the same denominator. Now let's say that you have a problem like this. You have 3/4 and you're adding 1/6. We can't add these yet because the denominators are not the same. It's like adding apples and oranges when your denominators are not the same. So what we're going to do in this case is we're going to make a factor list for the number 4, since that's the first denominator, and then we're going to make a factor list for the number 6. And the way that you make a factor list is all you do is you take that number times 1, that number times 2, that number times 3, that number times 4. When I'm multiplying by 1, 2, 3, 4, 5, 6, that's called multiples. And then you do the same thing for 6. 6 times 1, 6 times 2, 6 times 3, until you find something in the list that they both have in common. So the least common multiple for 6 and for 4 is 12. I did 6 up to 3, I see there's a 12 here, and I did 4, and I see there's a 12. So I can raise this fraction to 12 and this fraction to 12. Now that I have a least common multiple that I'm going to use for my least common denominator. You just compare the multiples. So this is how we would raise the fraction once we know that our least common denominator is going to be 12. What times 4 will give me 12? 3. So that means I need to take 4 times 3 and 3 times 3 because I want to keep it equivalent. 6 times what is going to give me 12? 2. So that means I'm going to do 6 times 2 and 1 times 2 to keep this fraction equivalent. So let's go ahead and raise these fractions. Now that I have raised the fractions to the correct denominator, I can go ahead and add. So what would my answer be here? 11 over 12. Can I reduce 11 over 12? No. So if I can't reduce it and the only factor they have in common is 1, I'm done. So let's just go over the steps that we did in order to add fractions that had different denominators. First, we found the least common denominator by finding the LCM, which is the least common multiple. Then we raised each fraction to that least common denominator. I wrote down the denominator that they had in common and went ahead and added the numerators. You'll do the same steps for subtracting too. Then you need to make sure that your answer is reduced or simplified to lowest terms. So, what would my LCD be for 5 and 10? Because I can't add these yet. What is a number that both 5 and 10 will go into evenly, the lowest number? 10. So I'm going to raise both of these to 10. Now on the bottom, I already have 10, so I just multiply by 1. But on top, what am I going to multiply by? By 2 to get 10. So to keep 2/5 equivalent, I multiplied both the numerator and denominator by 2, and 2/5 is equivalent to 4/10 because I need to make it in a denominator of 10. And then likewise on the bottom, I already had 6/10, so I don't really need to do anything. I just multiplied by 1 just so the problem looks balanced. But actually you could skip this part and just rewrite 6/10 if you like. So if I write 10 down as my denominator, what's my numerator going to be? 10, because I add 6 plus 4. And what's 10/10? 1. So you need to reduce if you can. Any questions on this problem? All right. What's my LCD going to be for 2 and 3? 6. So I'm going to raise my fractions to 6. On the bottom, I'm going to multiply by 2, and I'm going to get 4/6. And on top, I'm going to multiply by 3 to get 3/6. Now notice I also have a whole number. I like to just go ahead and take care of the fraction first. So my fraction here is going to be 4 plus 3, which is 7/6. And then I have the whole number 8 that I'm going to be adding. 7/6 is the same as 1 and 1/6. So I'm going to go ahead and make that a mixed number because it's improper. Take the 8 and add the 8. So what's my grand total going to be if I take the whole number 8 and add it to the mixed number 1 and 1/6? 9 and 1/6. So I like to take care of the fraction first. If my fraction's improper, I like to just go ahead and make it a mixed number and then add it to the total that I have for my whole numbers. That way I'm not doing a whole bunch of multiplying and dividing. For 10 and 12, what's the least common denominator? 60. If I did multiples of 10 and multiples of 12, I'll end up with 60. Here I'm going to multiply by 5 to get 60. I get 20/60. And here I'm going to multiply by 6 to get 60. I'm going to get 54/60. I add these together, I get 74/60. My whole number is going to be 15 in this case. So 60 goes into 74, 1 and 14/60. 8 and 7 is 15, so that's my whole number. I'm going to add that whole number to this mixed number, and I get 16 and 14/60. But can I reduce 14/60? By what factor? By 2. So that'll be 16 and 7/30. Because I got to divide these two by 2 to reduce it down. Are there any questions about these steps? What's the LCD for 6 and 9? 18, right? 6, 18. Yeah. So we're going to raise both of these to 18. On the bottom, we're going to multiply by 2 to get 14 over 18. And on top, we're going to multiply by 3 to get 15 over 18. When I add these together, I get 29 over 18. What mixed number is that going to be? 1 and 11 over 18? So this improper fraction, which is the fraction I'm trying to take care of first, ends up being the mixed number 1 and 11/18. Now I need to add the whole numbers. Don't forget your whole numbers. You've got 33 there. So when I take 33 and add it to the 1 and 11/18, what should I get? 34 11/18. Can I reduce 11/18? No. So if I can't reduce it, then I'm done. Just like addition, in subtraction, the denominators have got to be the same before you subtract your numerators. So in this case, what's my common denominator? 9, and when I subtract, I'm going to get 6 over 9. So I take 8 minus 2, I get 6 over 9. Then I take the whole number 11 minus 7, and I get 4. But I cannot forget to reduce. 6 over 9, what can I use to reduce it down? What factor? 3. Oops, I'm sorry, I didn't mean to go so fast. 3. So if I divide 3 into 6, I get 2. And if I divide 3 into 9, I get 3. So this is how I got 4 2/3, and that is as low as I can get because both 2 and 3 are prime. So I'm done. This is exactly the same process as adding. You have to get the same denominator and raise your fractions to that denominator. Then you're going to subtract the numerators instead of adding when you have subtraction. Now, subtraction has one caveat. Sometimes you have to borrow, and this blows people's minds because they're not used to borrowing fractions. But I am going to teach you how to do it. Okay, so when we get to a borrow situation, we will have several strategies on how to solve it. So let's go over the rules again. If the denominators are not the same, I have to find an LCD using the least common multiple factors. And there's other ways you can find the LCD, but I find that the factor list is just as easy as anything else. After you know what your LCD is going to be, you raise each fraction to the equivalence of that same denominator using multiplication. Then you write down the common denominator that you have and subtract your numerators. Simplify your answer at the end if you have to. If you have to reduce or simplify, then do so. So those are the steps. And I believe I put these steps, they should be throughout your packet everywhere. Page 3 and 4 gives you practice, and 5, finding the LCD and raising the fractions. So those first couple of pages will help you with your LCD. Then 6 and 7 deal with addition. You also have some for some word problems that you need to do as well, which I love. And then you have subtraction, which starts on page 14. Same process. It's going to have a little mixture with borrowing. And I talk about borrowing on page 16. You will have situations where you have to borrow. And these steps are listed throughout your whole packet. So if you look through the packet today, you'll see those 5 steps that I just talked about. And you also have some instruction on how to raise your fractions using the LCD. So, this is just an LCD practice. What's the LCD for 7 and 2? 14. You can just make a multiple list for 7 and a multiple list for 2. and the two of them have 14 in common. That's the smallest one. Remember, to do a multiple list, all you do is 7 times 1, 7 times 2, 7 times 3, 7 times 4, 7 times 5. And then you do 2 times 1, 2 times 2, 2 times 3, 2 times 4. But there's a shortcut you can use. Just take the largest denominator, do multiples of just that one, and compare it to the other. Okay, what about for 9 and 6? What did we say the LCD was? 9 and 6? 18, okay. So you guys are going to have some practice doing this. So you can stop and use 18. What about for 6 and 15? 30. And what about 3 and 13? 39. So just make a multiple list and find a number that they both have in common and just use that number. So what's my LCD for 3 and 2? 6. So we're going to raise everything to 6 here. The first fraction will be multiplied by 2 to get 6. So the equivalent fraction is 4 over 6. And the second fraction will be multiplied by 3 to get 6. So you'll get 3 over 6. So I'm going to write down the 6 and then subtract the numerators. 4 minus 3 is 1. So my answer is 1/6. What about the LCD for 4 and 5? 20. So the first fraction is going to be multiplied by 5. And the second one will be multiplied by 4. 4 times 5 is 20. 5 times 3 is 15. So you get 15 over 20. 5 times 4 is 20, and 4 times 1 is 4. So you're going to get an equivalent fraction of 4 over 20. What is 15 minus 4? 11. So your fraction will be 11 over 20. Keep the same denominator, 11 over 20. This is done just like we did addition. Subtraction is done just like addition. Now let's do some with mixed numbers. We know that 4 and 3 we need to raise to 12. And I like to put my fractions, especially if they have mixed numbers, vertically, like buttons on a shirt, so I can do all my work to the right instead of underneath. I'm going to multiply the bottom by 4 and the top by 3 to get my equivalent fractions. So I'm going to get 8/12 on the bottom and 9/12 on the top when I raise the fractions, which gives me 1/12 for the fraction, and I still need to subtract my whole numbers. When I subtract my whole numbers, I get 5. So my answer is 5 and 1/12. Done very similar to addition, except for I'm subtracting the whole numbers and I'm subtracting the numerators. Same process. Here I have 9 5/6 and 3 and 3/9, so I have to raise the fractions to 18. On top I'm going to multiply by 3. On the bottom I'm going to multiply by 2. Get my equivalent fractions. My equivalent fractions are 15 18ths and 6 18ths. When I when I subtract that, I'm going to get 9 over 18. But don't I need to reduce that? Yeah, so I need to reduce by 9, right? So my fraction is really going to be 6 and 1/2. Because I cannot forget to reduce. I subtract the whole numbers, and then I subtract the numerators once the fraction's been risen, okay? Don't forget to reduce. That's like your last step, is to make sure it's reduced. Now I have 4 and 10. What's my LCD? I have the denominator 4 and the denominator 10. 20. That's right, Alicia. So the top fraction is going to be multiplied by 5 to get 20. And the bottom is going to be multiplied by 2. So these are all the steps that we did to get 20, but you can kind of figure it out in your head. So on top, we're going to multiply by 5. On the bottom, we're going to multiply by 2. Now that I have my equivalent fractions, I have a problem. What's my problem? Can I take 18 away from 15? No. This is a borrow situation. I cannot subtract. Once I've raised my fractions, I can't subtract. So if I have to borrow, where am I going to go borrow? I got to go to the top fractions whole number and borrow. And how much am I borrowing? 1. So just like I would borrow in regular whole numbers, I'm borrowing 1. So I'm going to take 1 from the 4, and it's going to become a 3. Now what do I do with this 1 I just took away? It's going to be added to the 15 over 20. But in order to add it to the 15 over 20, I got to break it up. It's still 1, but I have to break it up into my common denominator. What was my common denominator here in this problem? 20. So the 1 becomes 20 over 20. Isn't 20 over 20 still 1? I just have to break it up into pieces so that I can make my fraction on top bigger. And the pieces are the common denominator over itself. So take 20 over 20 and add it to the 15 over 20 to get 35 over 20. Now I can subtract because I have 35 instead of 15. And what is 18 from 35? Oh, I'm sorry. How did that happen? 17? Okay, let's see. So let me go over those steps again. When I raise the fractions to the common denominator of 20, my numerators could not be subtracted because 18 is bigger than 15. This is a borrow situation. I go to the whole number on top, and I take away 1 number. This becomes 3 instead of 4. The 1 comes next to the fraction that was too small, and I break it up into the common denominator over itself. It's still equal to 1, but it's broken into pieces, like a pizza that you haven't eaten yet. Then you add that to the numerator to make it bigger, and I get 35 over 20. Now I can subtract. So when you borrow, you still borrow in 1, but you're just breaking it up into the common denominator over itself and adding it. We still need to take care of the whole numbers. What's 3 minus 2? 1. So my answer for this entire subtraction is 1 and 17 over 20. I hope we have another borrow. Yeah, here's another borrow. Why do I have to borrow here? There's no fraction, right? So I got to take 7/12, and there's nothing to subtract it from. So I come over to the 3, and what is the 1 going to look like when I borrow? Yeah, the only denominator I have is 12, so I'm just going to make this 12 over 12. That's still 1. 12 over 12 is still 1, but I have to break it up into the common denominator over itself. Now I can get 5/12 and 2. So when you have to take away, you got to take away. The answer here is 2 and 5/12. Any questions on this kind of borrowing? Nope. Okay. What do I do here? I have to borrow because there's no fraction for me to take the 24/25 from. So how do I borrow? Go to the 8. It becomes a 7. But what's the 1 going to be when I break it up? 25 over 25. When I subtract, I get 1 over 25. 7 minus 3 is 4. So even if you have a mixed number for your second term, you still have to borrow here because you didn't have a fraction. Okay, what's the LCD for 6 and 15? So both of these need to be raised to 30. And here's proof that it's 30. I did a multiples of 6, I did multiples of 15, and 30 is what's in common. I'm going to raise both of these to 30. On the bottom, I'm going to multiply by 2. On the top, I'm going to multiply by 5. So that leaves me with 25 minus 26. Is that going to happen? No, I got to go borrow. So, to borrow, what do I do? Go to the 9. It becomes an 8. Now, the 1 that I'm borrowing is going to be what over what? 30 over 30. It has to be added to that fraction that was too small. So now I have 55 over 30, which is more than enough to subtract 26 from. What will that be, by the way? What's 55 minus 26? No, not 3. 9. 29. So I have 29 over 30, and do I have a whole number? What's 8 minus 8? 0. I'm done. I just have 29 over 30 because there's no whole number. So these are the steps again. If the denominators are not the same, you cannot add or subtract yet. You have to find the least common denominator. You have to raise the fractions to that least common denominator, but make them equivalent. Then you have to subtract or add the numerator. Sometimes you have to borrow in subtraction if you don't have enough to subtract. Write down the common denominator, do your addition or your subtraction, and then don't forget to reduce or simplify the fraction. So these are all the steps for adding and subtracting fractions. And you need to complete your study guide. Let me get you started on your study guide a little bit. I know some of you had started it already, but let's take a look. So after you finish the packet, you're going to check your answers, and then you're going to do your pre-test and post-test. So page 2, what are you supposed to do here? Page 2 is just simple addition. Are the denominators the same on page 2? So this should be fairly easy. What's the answer to number 1? If I take 1/2 and I add 9, how much is that going to be? 9.5. You just add them. You got a whole number and a fraction, you just add them. What about number 2? The denominator is the same, so that means I can go ahead and add the numerators. I get 10. But I better reduce that. So what does that become? 1. And then on number 3, I'm going to add the numerators. The denominators are the same. So what's 3 over 3 equal to? So if I take 2 plus 1, how much is that? 3 altogether. So my answer is 3. The fraction turned out to be 1, and I just add that 1 to the whole number, which is 3. Number 4, you're going to have 5 over 6 for the fraction, and the whole number is 11. On number 5, you're going to have 7 over 5. What is 7 over 5 as a mixed number? 5 goes into 7 one time. I have 2 left over, and I keep the same denominator. So I have the mixed number 1 and 2/5. My two whole numbers add up to 5. So my answer is 6 and 2/5 for that problem. My whole numbers are 5. My fraction turns out to be 1 and 2/5. When I add these together, I get 6 and 2/5. What's the answer to number 16? What's number 16? Hello? Number 6 here on page 2. Page 2, number 6. 13 and 3/4. You just combine them. So I think you guys know how to do this one. This is pretty easy because the denominators are already there for you. Now at the bottom of page 3, you guys were supposed to just find what the LCD is. So let's just find the LCD for these. What's the LCD for number 1 where I have 6, 2, and 3? And what about for number 2? And what about number 3? And what about number 4? 8. Okay, those are pretty easy. Let's do, what about number 9? Number 9. Let me put that up here. What is the LCD? Just take the largest one, which is 9. So 9 times 1 is 9. 9 times 2 is 18. Well, 9 goes into 9, and 9 goes into 18. 4 goes into 9, no. 4 goes into 18, no. So I got to keep on going. What's 9 times 3? 9 times 4. 36. 9 goes into 36, 4 goes into 36, and 3 goes into 36. So this is my LCD. That's a shortcut. Instead of writing all the multiples for 9 and all the multiples for 3 and all the multiples for 4, if you will just take the largest denominator, write multiples for it, and compare it to the other 2 or 3 numbers to see if they go into it evenly. And basically 4 doesn't work until you get to 36. But both 9, 4, and 3 will all go into 36 evenly, so that's how I'm doing this one. Let's do number 10. 16. Will 8 go into 16 and will 4 go into 16? So 16 is it. 15 is the largest. Will 2 go into 15? No. So 15 times 1 doesn't work. But what about 15 times 2? Okay, will 2 go into 30? Will 10 go into 30? So that's my LCD. So that's just a shortcut when you have a group of them, okay? And what about number 12? Does 32 work? Yeah, 32, everything goes into 32. So I just wanted to show you the shortcut in case you want to use a shortcut for getting your LCD. You need to all do 5, 6, 7, and 8 on that page if you have not done so already. I'm not going to do those. On page 5, you're going to not only find the LCD, but practice raising the fractions to equivalent fractions on this one. So what is the LCD on number 2? No, it's 8. LCD means the least common, the lowest number that will go, that all of them go into, and that's going to be 8. So you just write the fractions that you have initially down. You know that all of them need to go to 8. And then you just raise your fraction. 4 times 2 gives me 8. What I do to the bottom, I do to the top. So the equivalent fraction is 6/8. 2 times 4 gives me 8. What I do to the bottom, I do to the top. So that equivalent fraction is going to be 4/8. And we already have 8 on this one, so I'm just going to do it by 1. And we have 7/8. This is the entire process there. You find out what your LCD is and you raise the fraction to that number. Okay? Let's do problem number 8 down there. That looks interesting. What's the LCD on problem number 8? No, it's 18. 36 will be bigger. Because you'll just take 9. 9 times 1 equals 9. 3 goes into 9 evenly, but 6 doesn't. 9 times 2 is 18. 9 goes into 18. 3 goes into 18 evenly, and 6 goes into 18 evenly, so your LCD is 18. Then you just raise the fractions. You have 8/9, 1/3, and 5/6. All of them are going to be 18. On top, we're going to multiply by 2 to get 18. Here, we're going to multiply by 6 to get 18. And here, we're going to multiply by 3 to get 18. So my equivalent fractions are 16/18, 6/18, and 15/18. Those are the answers that you need to have. So this whole page is practice getting the LCD. Remember, get the smallest one that they all have in common, that they all go into evenly. Raise the fraction and show me what those new equivalent fractions are. Was there another one on this page you'd like to do, or you guys get it? Is there another one we need to do on here as an example? Or you guys understand it? Number what? Number 12. Okay, let's do the number 12. What's the LCD? 32. So we have 17 over 32, 6 over 8, and 15 over 16. Well, on top, this one's already 32. So we're just going to multiply by 1. 4 times 8 is 32. So 6 times 4 is 24 over 32. And then 16 times 2 is 32. So that equivalent fraction is going to be 30 over 32. So you just raise all the fractions to 32. And those are your equivalent fractions that you need to show me that you know how to do. Okay? You guys finished the rest of the ones that we did not do together. On the bottom of page 6, we have addition of fractions where the denominators are not the same. So let's do a couple of these. What's the LCD on number 1? We have 8. So 8 times what? What about 8 times 3 is 24, right? So I think it's 24. You have 7/8, you have 2/3, and you have 3/4 that you're adding. They all need to be raised to 24. Here you're going to multiply by 3 and gives you 21 over 24. Here you're going to multiply by 8 to get 16 over 24. And here you're going to multiply by 6 to get 18 over 24. So you know 24 is your common denominator, and you need to add. Let's see, this is a 7, 37, and 18. I get 55. Now, can I leave my answer as 55 over 24? No. How many times will 24 go into 55? And what's left over? I get 7 left over, right? So 2 and 7/24 is what I have there. 49, 24 times 2 is 48. And then when I borrow, I have 15 minus 8 gives me 7. So I'm getting 2 and 7/24 as my answer. 2 and 7/24 because 7 is my remainder and 24 is my denominator. What's the LCD on number 2? 18. So you're going to take each of these and raise them to 18 and then add the numerators. So you got 19 plus 15, 34. Now 18 will go into 34 how many times? At least once, right? So I got 1 and 16/18. Can I reduce that? What goes into both 16 and 18? 2, right? So I get 1 and 8/9. I had to reduce the 16/18. And then let's do the third one. What's my LCD for number 3? 20. And I'm going to multiply this one by 5 to raise the fraction. I'm going to multiply this by 10 to raise the fraction. And I'm going to multiply this by 2 to raise the fraction. And that'll give me 39 over 20, which is 1 and 19/20 when I add them, and I can't reduce that at all. 1 and 19/20. Are there any questions on page 6 in the 3 problems that I did that do not have the same denominator? So what I want you guys to do is go ahead and work on this addition portion, and then after break, we're going to have break in about 5 minutes. After break, around a little after 10, if you have any questions on the word problems or on the subtraction, let me know which ones you have problems with and we'll do those together, okay? So right now I'm going to go ahead and stop the video and we will come back to this after break.